Alright, who can give me the regression equation? It starts off selling price equals 97.89. Alright, someone else continue, please.
18%, right?
98 points
Plus 18%,
plus
or point 0.1854.
0.185.
4.
Okay,
Would you say 18% or no?
it's not in percent, right?
Oh, it's not.
Yeah, it's not. It could be. The last example it was, but it's not this time.
Oh,
Times what?
21898.
Times house size, where's,
Times house size. Plus, what was it again? It was 0.185
5.
times size.
5,
Yep. All right. And next,
plus,
Private Wendy.
Plus
plus
218.
218.
Oh, sorry, Dina. 218.
218.989.
Wait. Oh, 218. Yeah.
Yeah.
218.
0.989.
0.99 times
Zip. Zip.
zip. Which zip code?
98026.
98026. Excellent. And what's next? Is that it? Yeah, that's it, right? Okay, good. Okay, so how do we interpret that? So this size is in thousands of square feet, I believe. So if you have 150,000 square feet, you put 150 in here, and you multiply that by 0.185, right, and you're going to get selling price in thousands. So for every 1,000 square feet, how much would you expect your selling price to increase?
0.185.
$185.
How much?
$185.
Sounds right, I guess. I get confused. I always get confused because it's in thousands and then the selling price is in thousands. Is that right? If you say it's right, I'll believe it.
Are you serious?
So-
The 0.185 is in thousands, you said?
The result, the answer is in
Oh, not the
thousands.
point.
Yeah. So the actual output is in thousands.
$185.
So you put in 1 here, it would be $185. For every 1,000 square feet units, your selling price increases by $185. Okay? And how about this one? How do we interpret this? First of all, what do we put in for location? So I should probably just put location here. So I'm going to change this to location, because it could be location. Okay, what do I put in there? Do I put in 12? 0? 1? -2?
0 or 1.
0 or 1. When do I put in 1?
If the house is in zip code 98199.
Yes, the house is in zip code 9819. I put in 1 here, and how much would I expect my selling price to increase if I'm in that zip code?
One times,
Yeah, that's 218,000.
one time it's
Yeah, 219,000. So if I'm in that neighborhood, so Kelsey, you have a house in that neighborhood. What was it again, Keisha?
98199.
In that neighborhood, you have a house in that neighborhood, right? And Tang has a house in the other neighborhood, exact same size. How much more would we expect your house to sell for? 219,000. Yeah. What do you think?
what the wrong house.
$18,000 more.
Yeah. And this is real data. And 2 zip codes in Seattle.
Location.
Location, yes. Alright. Just real quick, can somebody just give me some thumbnails on the performance data? Maybe just tell me R squared and adjusted R squared and standard error. You don't have to do the multiple R. We're in a hurry. Just 3 out of 4, right? Alright. Alright, let's start with R squared. Okay. Yes, we can explain 50% of the variation. So what do you think? Are you impressed by that? Is that low, high?
Almost impressed, but not completely convinced.
So, I mean, it's not a lot. It's a significant amount. It's 50% of the variation. What I might take that to mean is there are a lot of unique factors in the housing market. So if we can explain 50% of the variation, I'd say that might be worth something. Adjusted R squared, remember that penalizes if you add extra variables that don't help very much. So we get a slight little bump. I don't know if we'd worry too much about that 5% decrease. How about this standard error of the estimate? What is the standard error of the estimate once again?
I don't wanna say the average, but the distance,
And the housing.
You
the
can
standard
say,
error is the distance from the,
it's actually the average distance
so now it's
from.
average distance?
It's the average distance from.
From,
Last time you said the average distance from the average.
oh,
And that's not right. It's the average distance from,
the regression plane, because it's moving.
the average distance from the regression plane, and it's 137, what units are we in here? 137 what? $1,000. Yeah, so that's a lot, right?
Yeah.
137,000. Each of these 20 houses on average is 137 off from the regression plane.
$137,000 off?
Yeah. Yeah, so if we were to draw, I know it's a plane, but if we were to draw a line of best fit, alright, these dots would be like this. The average distance from the line would be 137,000. So, what do you think? You're skeptical, right?
Right.
You're like, I don't really know if I like this model now.
Well, 'cause
So that's like what, if it's the listing, if it's the selling price, that means some of them are $137,000, like overpriced, and some are underpriced?
Yeah, some over, under, just the average distance. Sort of the average variation that we could not explain is 137,010.
Well, it makes sense because our dummy variable is there's a difference of $218,000.
This is with the dummy variable. Okay, so if we include the dummy, if we account for the dummy variables,
Right.
we have a different, I drew a line, but it's actually a plane.
Right.
So the dummy variable helps us and brings that average distance closer. But even still, even the fact that we know the location and we know the size, they're still on average 137,000 away from where we would predict them to be.
Even within its own zip code? Let's say we just took one of the zip codes.
Okay, we can try that. In fact, do we have the data? Yeah, we have the data.
Do I want to?
Try that for us?
No, I was just wondering out loud,
Yeah.
would that same variation hold?
I don't know.
Okay.
I don't know. But I mean, it's not. This is not an unusual question. We say, all right, how close are the points from where we would predict them to be? Well, they're 137,000. So if you want a model that explains within 1,000, then this is not your model. But this is still a pretty good model, maybe. I mean, well, actually, we haven't gotten to some of the reasons why we would say it's a pretty good model, so. Not quite about that. We just know R squared is 50%. All right, so what are the reasons I might say this is a pretty good model overall? What's the thing I would look at overall, Kelsey?
Your F-stat.
F-test. What does the F-test tell us? Overall, okay, fine. What are you looking at with the F stat that makes you say it's significant?
It's greater than one.
Okay, it's greater than 1, that's true, we just don't know how to quantify that. What do we really look at that we do know how to quantify?
The significance of your whole regression analysis
What is it?
for 8.5.
Helps that, do you?
I thought we were looking at the significance of F.
Yes, and what is it in this case?
Less,
0.00279?
yes,
Do you like that, so that's in percentage, so that's 0.3%?
right,
Do you like that it's low?
yes.
What does that indicate to you that it's really low?
It's,
What is a really low F significance tell us?
That we can reject the null.
Yeah, and what is the null we would be rejecting? All the slopes are 0, no predicted value anywhere. We have a really low p-value for our F, so we can reject that. Forget that noise. We have something statistically significant, like super low, 0.3%. Alright, so based just on that, we might say, strong model. Yeah. Alright, so even though it just explains 50% of the variation, that's a solid 50% of the variation. We're of course going to need to count for some other factors like style, age of the house, all that kind of stuff. But just these two factors alone, they tell us some significant things. They explain the variation. Alright. So we looked at the F-test, tells us overall this model is pretty good. Let's look at the p-values for the individual coefficients. What do you think when you look at those two?
Well, the p-value for the zip is pretty low.
they both
Yeah, they're both pretty
They're both
low.
pretty low.
Yeah, so how does it make you feel? Both of them being pretty low?
Yes, let it go, reject them.
Reject the null hypothesis and say, but these individual slope coefficients are both pretty low?
Yes.
Now, does this model suffer from the problem of the F-stat being really low and the T-stats being not so low? Remember the last regression analysis with the basketball thing? We had a really low F-stat and we had kind of questionable T-stats. And we said the reason that might be happening is what?
because of multivariate.
Multicollinearity. Alright, the independent variables in that case, in the basketball example, were related to each other. We don't really see that. We see really low F-stat and really pretty low T-stats too. So what does that tell you? Do you think we have a multicollinearity issue?
No.
No, these two independent variables are probably not highly related to each other. So just because a house is in a certain zip code doesn't mean it's going to be bigger or smaller. It's not like we have all big houses in one zip code and all small houses in another zip code. Probably completely independent. Because the house was probably built years ago, before we even felt this was a good neighborhood or bad neighborhood. Probably built like 100 years ago, when it was the best neighborhood, and now it's like the worst neighborhood. So property values went down for some bizarre reason, who knows? Alright. Good, good. Great. Alright, so that's dummy variables, that's multi-regression analysis. Next week we'll do chi-squared tests, which are pretty easy, I think, and a good summation of a lot of different things that we've done over the course of the quarter. And we'll have some time at the end of class next time to do some review if you'd like to. We'll probably just do about half an hour, or no, it'll probably take us about an hour and a half to do chi-square, and then we'll have some time to review if we need to. But great work tonight. See you all next week.
Probably